The ambiguous case. So just like we talked about before, where I might have an example, and actually let's use the example that we had where we had the issue come up. So let's say I was given a question. I was given a question and it said that my angle here was 60, this side was 12, and this side was 10. Okay. When I'm given this information, there's a couple things that can happen. Okay. First off, the 60 degrees. Are we dealing with an obtuse angle or an acute angle? I wouldn't say probably, I would say it absolutely is an acute angle. Why is it an acute angle, not an obtuse?
It's little and it's cute.
It's little and it's cute. Okay? Specifically, how little is it? It's less than 90 degrees. I like that analogy. It's little and it's cute. Specifically, it's smaller than 90. Alright? Obtuse would mean it's bigger than 90, right? So, in this example, because we're dealing with an acute triangle, I'm actually going to give you a little bit of a cheat sheet here. Okay? Essentially, what can happen when I'm given information with regards to a triangle, the information I might give you can give you 3, if not 4 different situations. Situation number 1, I might give you information that doesn't actually create a triangle. That cannot exist. Thanks for that, Mr. D, right? Appreciate that. Option 2, it might be something that has 1 solution. Or option, I guess there's only 3 options. Option 3 is that there's 2 solutions. Okay? How we can figure out if we have 0, 1, or 2 solutions. The first thing I want you to do is remember we talked about the height or the altitude. So if I want to find out, I'm going to use a different color. I want to find out specifically what this height is from this line, that 60 degree, all the way up to the point. And obviously my calibration's off because I'm a little to the left. But I want to find this height right here. In order for me to find that height, I actually take my information of what I know, and actually specifically, I can use, if I break this down into a right angle triangle, I have my opposite, I have my hypotenuse. Does anybody know what trig ratio uses opposite and hypotenuse? I want 5 hands to think they can figure it out. 1, 2, 3, 4, 5. Wow, I got more than 5. Curtis, do you know what it is? Good. Sine law. Absolutely not sine law, but it's the sine ratio. I can use sine theta is equal to opposite over hypotenuse. In this case, sine 60 is equal to my opposite, which is my height, over the hypotenuse, which in this case is 12. How do I solve this to get h by itself? I have to multiply by 12. So my final answer becomes 12 sine 60 is equal to the height. The formula that supports that, let's say I gave you this example. I said this is A, this is D, this is B. And then that means that this imaginary angle, depending on where it's at, is C. Okay. How I find H, H is actually equal to, I'll put it over here, blue. H actually becomes equal to the I guess it's the hypotenuse, which we use 12. What side length is that? What would be labeled? If I use the ABC label, it's side C. So I'm going to use a smaller, lowercase c. Multiplied by sine of, what's this angle 60? It's angle A. So basically what I'm using is I'm taking the opposite side and I multiply it by the angle I'm given. And that gives me my height. Can anyone tell me what 12 times sine of 60 is actually equal to? 10? Even? 10 point? Okay, so 10.4. Alright. That number is significant to us. Because if we go back to our cheat sheet, we have a couple scenarios. Our first one, specifically, is this guy. if A is less than H. H is 10.4. Okay. A is 10. Which one's bigger? H. H is bigger than A. When that happens, we don't have a solution. Okay? Because if I were to connect these 2 points together, I lose the ability to have 60 degrees as my angle. Okay? What it's saying is that there is no point here where it will actually ever cross so that it can connect at 60 degrees. Okay? So the only way I know that is by checking to make sure that my H value has to be less than my A value. Okay? So right now we have no solution. As it stands, there's no solution. It does not exist. I'm going to copy this page for a second. So now using this information, we know H. What can we do to that 10 to make this a legit triangle? Is there another number we could use? We could go higher, so give me a number that's higher than 10. And that would be higher than the 10.4. So let's try to get above that 10.4. 10.5. Cutting her close. Okay, if I go 10.5, now I check my graph, and let's change this stuff now. This now becomes 10.5. So now what does this read? Is A bigger or smaller than H? A is bigger than H. So let's go back to our cheat sheet. Where, option 1, 2, 3, or 4, do you see A is bigger than H? The last one. And actually this one's true because A is bigger than H, but if I go back to my example, 10.5 is smaller than 12. So now this reads this way. A is bigger than H, yes. However, B, or in this case C, is bigger than A. Right? If we have this scenario, we have two possible answers. Okay? The only time you would come up to a point where you would have two solutions. So let's draw this a little bit better. Okay, so 10.5 we'll say is a little bit taller. So we'll say it's actually around, well, let's say it's here. Okay? Still gives us 60 degrees at 10.5. The only time you would have this type of a question would be if you were to find out what this angle is. If you were asked what is angle C. Okay? Option 1 is finding out where that triangle or that angle is. What this 10.5 represents is that if I keep this as my hinge, I can actually rotate this triangle over here, and this will still be 10.5. I'm going to put it over here. However, the first angle was an acute angle. What is this one now? Obtuse. So what they're saying is that you could have two types of triangles. You could have one that provides all acute angles, and we could have one that includes an obtuse angle. Okay? That makes sense? A little bit? One of the questions that came up last day was, how do I solve? How do I solve for that? The suggestion I would give you is that I would solve based on your acute angle first. Okay? So I'm looking for an angle. That means, so triangle 1. I'm looking for angle C. That's equal to the inverse of sine of the side that I know, or sorry, the side that I'm given multiplied by sine of A divided by side A. So C is equal to the inverse of sine. What was our side C? 12. What was the angle we knew for sure? And Jared's side was 10.5. Can someone try to put that into their calculator and see what that angle comes out as? Okay? You always have triangles that will give you one specific answer. Okay? Does anybody have an answer for me? 81? Can anyone confirm 81 degrees? Yes? It's actually rounded to 82? Is it?
Yeah.
Okay, good. That's alright. That's why we have people confirming it. 82 degrees. Is that an acute or an obtuse angle? It's acute. Okay, so what that means is if I were to draw this triangle, the first triangle that I would draw, this one here is 60, this one here is 81, okay? This is 10.5, and this is 12. Option 2 looks like this, okay? Where this is still 10.5, but I need to find out what this angle is now, right? What do we know about straight lines? This isn't actually a very good representation. I'm going to make this a little bigger. It's not, yeah, that looks a little, that makes a little more sense. Alright. I'm going to erase that. Just say that this angle is 60. This is the angle we're trying to find. That does not look very nice. Okay. If I look at this new triangle, so this was the original, yes? The acute angle. Option 2 has the angle that has the obtuse side. Can I create, what type of triangle does this actually become? Anybody have a label for it? I don't even need this side. Does anybody have a label or a classification for what type of triangle I've just created here? I'll give you a hint, starts with an I.
Isosceles.
An isosceles. Why is it an isosceles triangle?
The two sides are the same.
This is 10.5, and this is 10.5. What do we know about an isosceles triangle if they have two sides that are the same? What's happening with their angles? The two angles are the same. So this angle here has to be 81. What do I know about a straight line? What's the degree of a straight line? 180. If I know that I have 180 degrees total, and I have 81 as one part, could I not find that third angle? What's 180 minus 81? 99. So that tells me that I could have two answers for angle, in this case C. Angle C could equal 99 degrees or 81 degrees. That's how I would solve the ambiguous case and labeling and acknowledging, Taylor, that we have two possible angles. That make sense? It's a lot. So feel free whenever those questions come up where they have to say, give all solutions. The big thing you want to look for, if I could give you a spark note, is if I give you a triangle, if I give you an angle of 45 and I give you this is 15 and this is 12, always look at this side here. Okay? if this number is bigger than this side, you know that there's only one answer. Okay? If, however, this side is smaller, you have to determine if this length is larger than that length. Because it has to be. If it's not, what happens? What do you think? There's no solution, doesn't exist. Okay? Does that help? It'll be more helpful whenever you guys try some, and I'm going to give you some time Thursday and Friday to work on them, alright? Awesome. I'm going to move on to cosine law. Where are you? There we go. And I'm going to stop, gentlemen.